Okay, so this video is just a couple more examples with ellipses. For those of you that need or want more examples, especially examples with an ellipse that has a vertical major axis. So 2 examples similar to the ones we did and the ones I did in the other video. But just mixing it up by making 2 videos. Why not? So let's go ahead and start with taking an equation that's not written in standard form, rewriting it in standard form, finding all the info about it, and then graphing it. So let's do this example of 4x squared plus y squared minus 8x plus 4y minus 8 equals 0. And we're going to rewrite the equation in standard form. So once again, we want to get the x's by x's, y's, number on the other side. Here, I'm going to skip a step. No, I won't. So I'm going to bring the x's together. 4x squared minus 8x, and then plus y squared plus 4y equals negative 8. So basically, x's are grouped, y's are grouped. I goofed. We want to add 8 to the other side, so we get a positive 8 there. Boom. There we go. Cool. Sorry. Plus 8. Positive 8. So now I want to go about completing the square. This is going to be simple to complete because it's just a y squared and a 4y. But here I've got this 4x squared, the 4 out front, so I'm going to factor out that 4 just like we did before. 4 before. So 4 and then x squared minus, nope, not 8x. Wow, I'm just like off today. Yikes. X squared plus, well, 8 divided by 4 is 2. So it's actually x squared minus 2x. And then plus blank plus y squared plus 4y plus blank equals 8. Go about completing the squares, right? Divide that by 2, square it, we get 1. So I need to add 1 to both sides. Divide that by 2 and square it. 4 divided by 2 is 4. Oh. Sorry. 4 divided by 4 is 2, and 2 squared is 4. Just brain's working faster than my mouth is. Plus 4, plus 4. There we go. Can you see where I goofed? Find where I goofed. Look at it. Pause it. Find where I goofed. I goofed somewhere. It's right here. And this is a mistake that often happens, what you gotta look out for. I added 1, right? But how many times did I add 1? 4 times. So really, I need to add 4 on both sides here. Boom. Because I'm adding 4. Because I'm adding 1 4 times. And I'm adding 4, so it's plus 4 plus 4. There we go. Sorry about the goof. That was not intentional, but hopefully it served a learning purpose. Yeah. All right. So let's go ahead and square that. Or let's square, oh my goodness. Let's complete that square. So 4 times x minus 1 squared plus y plus 2 squared equals 16. There we go. That's better. Wow, hopefully the rest of this video goes better than the start of it has. Yeah, alright. So now I've got the squares. Wonderful, it's what I want. But I want this to equal 1, not equal to 16. So we gotta divide both sides by 16. Divide by 16, divide by 16, and then simplify. Here I get x minus 1 squared over 4 equals, oh my, where did that equal sign come from? Just all over the place today. Goodness gracious, yikes. Plus, that's an addition symbol, plus y plus 2 squared over 16 equals 1. Boom, we got our equation. There's our equation. That is not all that's getting asked for, but that's the link that's going to give us the rest of the information that we want. All right. From this, now we can easily find the center. The center is going to be at 1, comma, negative 2. Right, it's the opposite of the x for the x, opposite of the y for the y. Now I can find, it doesn't ask for what a and b are, but let's go ahead and state what the a value and the b value are. The a value in this case, well, a squared equals 16. A is always, okay, so thing to remember, a is always bigger than b with ellipses. So here we're going to get a vertical major axis ellipse because the 16 is under the y. So the bigger value, the a value, is under the y, which means that major axis is going to be in the y direction, it's going to be vertical. So here, a equals 4, because a squared is 16, and then the b value, b squared is 4, so b equals 2. That's going to help us find our vertices and covertices. It's also going to help us find our foci and what the c value is. So here, let's go ahead and just start graphing though. Let's do that. Let's get some pen. Which pen to use? Let's use the white pen. Shows up fairly well. So 1, negative 2. So 1, negative 2. That's our center. Now, if I want to find my vertices, I need to go a distance, so in other words 4, away from the center. And in this case, it's going to be up and down. So I'm going to go 4 up, 4 down. So 1, 2, 3, 4. That's going to be a vertex. And then 1, 2, 3, 4 down. That's going to be another vertex. They're still sharing the same x numbers, so the y number on these has changed. So here, my vertices are at same x number, but the y number plus 4 or minus 4. So if I add 4 to negative 2, I get 2. And you'll see that point is there at 1, 2. And we're going to have the other vertex at 1, negative 6. Because negative 2 minus 4 puts us down at negative 6 there. All right, so we got the vertices. Let's find the covertices. Let's use a different color too. So covertices are going to be at, well, they're going to be on the minor axis, which in this case is going to be horizontal, and they're going to be 2 away, the square root of that number away in that direction. So 1, 2 away from the center, and 1, 2 away from the center. So co-vertex there, co-vertex there. Now we can draw in the shape of our ellipse. And these don't have to be perfect. Just don't make it look like a diamond. Don't just go like straight, 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 straight. Make it nice and smooth and do your best to make it look kind of like an ellipse. Right? They're not straight lines. It's not perfect, but it's good enough. Ooh, that was probably loud on the phone there. Okay, so let's go ahead and write in what our covertices are. So the 1, we add 2 to it. We get 3, negative 2. Because we changed our x numbers, but the y numbers stayed the same, right? So we're going horizontal with this. And then the other one is at negative 1, negative 2. That's our other covertex. All right, so we just went right or left the b value, right? So 1 plus 2, 3, 1 minus 2 is negative 1. So we got our vertices, our covertices, and our center. We also need, well, and from this, sorry, this pretty simply, now we can find the major axis length. All right, so major axis length is here to here. So it's 3, and so it's 4, 1, 2, 3, 4, and 4, which is 8. And then the minor axis length, minor axis length is here to here plus here to here, so 2 and 2 makes 4. All right, wonderful. We got that info. Those just kind of come together nicely. Now what we need to do is we got to find the foci. So to find the foci, we're going to use the a and the b value. Let's use this red pen for the foci. So we need c squared equals a squared plus, goofing, a squared minus b squared, it's an ellipse, not a right triangle. A squared minus b squared. be careful with that formula, right? Your brain has been programmed to think a squared or c squared equals a squared plus b squared from that Pythagorean theorem. But we're using this this formula with an ellipse. It's not a Pythagorean theorem. They just also happen to be a's, b's, and c's that are squared. So here, c squared equals 16 minus 4. So c squared equals 12, which means c equals root 12, which is 2 square roots of 3, right? Because this is square root of 4 times the square root of 3. So 2 root 3, right? Whatever 2 root 3 is, it's like 3.5-ish. Let me just double check it on the good old calculator here. Yeah, not that button. Yeah, 3.46. So, ish. So it's a little less than 4, right? Well, yeah, not too much less, but yeah. So what we're going to do is to put those foci on there, we're going to go about 3.5 up and about 3.5 down. So those are our foci, and we're going to label them, put little arrows. And then we're going to write the coordinates for the foci. So here, what we got to do is we're going to say, all right, the x number on these foci are the same as the x number on the vertices and on the center, because those are all in the same vertical line. So the x numbers are the same, they're all at x equals 1. So 1 comma, and then 1 comma. Now the y numbers are what changes. So what we're doing is we're starting at the -2 from the center, and then we're adding this c value to it to get that focus. So we have -2 plus 2 root 3, and then we're starting at the center and we're subtracting the c value to get that focus. So -2 minus 2 root 3, and those are our values. Or sorry, those are our coordinates for our foci. Okay, the last thing we gotta do for this problem is find the eccentricity. Eccentricity in this case should be kind of closer to 1 than to 0, because these foci are close to the vertices. If the foci are close to the center, then your eccentricity is going to be close to 0. So here, eccentricity E equals c over a. It's going to be 2 root 3 over 4, right? 2 root 3 is our c value, 4 is our a value. It's about 3.5 over 4, or about 7/8, right? Yeah, about 7/8-ish. So kind of close to 1. All right, and that's, I believe that's it. That's all we have to do there. So hopefully this made sense. Sorry for all the goof ups. I'm going to jump to the next example where we're given some information and we graph, find all the other info, and write the equation from it. So let me erase that. We're going on that example. Erasing. Let's switch to a clean side to erase some more. Don't fall off, pen. Dry it off. Make it look nice and clean. There we go. Okay. Go orange. So here we have vertices at 3,1 and 3,11. So same x number, different y numbers, and the minor axis length. So the minor axis length is 2. That's the info that we're given. We want to find the rest of the information about the ellipse along with the equation and sketch a graph of it. So here, the minor axis length is 2. So that means the b value is 1. It's half that length. The b value is half that length. The vertices lie on your major axis. So the major axis is, well, here the x numbers are the same, the y numbers are different. So if we're going to graph this, we might as well just like start graphing it. Let's use this pen. So we're at, let's go like this. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're at 3, 1, and at 3, 11. Those are our vertices. So it has a vertical major axis because the x numbers are the same, the y numbers are different. These 2 points are 10 apart, so halfway between them is going to be 5 away, but it's not the number 5, it's going to be at 6. If you're like, oh, I don't know how to do this, my brain's not working, just add these 2 numbers together, 11 plus 1, and then divide it by 2. In other words, take the arithmetic average of them, and you'll get the center. Is that what I was trying to find? I don't know. I just did it, sorry. The center is going to be 5 away from each. So we found that. So 5 up, which gives us that our a value, a equals 5, right? Because that major axis length is 10, so half of that is 5. So here, a equals 5. The center is at 3, 6, which is either 5 above that one or it's 5 below that one. I mean, it's both. All right, so we have the center, we have the a and the b. We can now write, that's enough for the equation. Let's go ahead and write the equation. The equation is going to be x minus the x number of the center squared plus y minus the y number of the center squared with the equals 1 there, and then we have to divide by the a squared and the b squared. So here, because we have a vertical axis, our vertices are up and down above each other. The 5 squared, or the 25, the a squared, is going to go below the y part. Here, the b is 1, so 1 squared, that's going to go below the x part because the minor axis is horizontal. So we've got our equation, we've got our center, we have our vertices. We can now easily find our co-vertices. So the co-vertices are going to be just 1 to the left and right from the center. So 1 to the right, 1 to the left. So co-vertices are going to be at the same y number, because we're on that horizontal line here, but the x number is going to go 1 to the right, so 4, 6, and then 1 to the left, 2, 6. You can see that there. And that's enough to get that shape of our ellipse drawn in. Obviously, it's not perfect because I'm just drawing it by hand, but you get the idea, right? There's our graph so far. And also, right, we got the, well, I didn't write it, but major axis length. Major axis length is going to be 10, right? Because it's twice the 5, that's 10. That's your major axis. All right, we also want to find, basically now we're just going to find the foci and the eccentricity. I think that's all that's left. I put all the stuff on the problem so that you fill in each one so you don't forget anything. Because it is really easy to forget stuff. Like, there's so many things going on with these ellipses. All right, so we've got our a value and our b value. So for the foci, c squared equals a squared minus b squared. We're going to use that. So c squared equals 25 minus 1, because 5 squared is 25 and 1 squared is 1. So c squared equals 24. So c equals the square root of 24, right? Because 24 is 4 times 6, right? It's 2 square roots of 6. And it's going to be just like a little bit smaller than 5. So here it'll be a focus there and a focus there. Remember, the foci are always on that major axis. They're always somewhere between the center and each vertex. Not the co-vertices, but the vertices. So foci, focus. So foci are here and there. And the way we write the values of these, so for our foci, let's get a different color here. Let's just use red. Red's the focus color, I guess. So for the foci, they've got the same x number as the center, just going up and down. So the x number is still 3, but we're taking the y number and we're adding the c value, so 2 square root of 6, And then we're taking the x value, same x value, and then the y value of the center minus 2 squared root of 6. Sorry, Google thought I was talking to it. No, Google. Okay. Oh, last thing, eccentricity. Okay. Lastly, we've got to find the eccentricity. Eccentricity, which is E equals C over A. The C value is 2 root 6. The A value is 5. And that's just what our eccentricity is. It's 2 root 6 over 5. And because 2 second square root of 6 divided by 5, it's about 0.9797. This is like a real skinny, like hot dog, not circle ellipse. So this is close to 1, so that tells us if we just knew the eccentricity, that would be a flatter ellipse. Okay, so that's that. Hopefully this is enough. It's only, once again, it's only a 5 problem assignment. These problems do take a little bit longer, but yeah, hopefully you can do it. Email me if you have questions, please. All right, thanks.